Welcome back. Let's talk about SI units. SI units are basically just metric units with slight modification. They're the units we use in science and around the world to measure all the empirical stuff around us. Now, SI stands for Système International. It's French, pardon my pronunciation, and it simply just means the international system. There's quite a few SI units and they measure all kinds of different things, but I usually just have my students memorize the most important 5. And those are meters, written as a lowercase m, grams, written as a lowercase g, liters as a capital L, seconds, lowercase s, and for temperature, any guesses? Kelvins, capital K. Now, all of these units have these one-letter abbreviations. It's really important to note that with all your units and your unit prefixes, the casing matters. Lowercase m, as I said earlier, means meters. Capital M means mega, which is a prefix which means 1 million. Lowercase g is grams. Capital L is liters. And again, the capital here is really important. Lowercase l kind of looks like a 1, right? So a capital L stands out. Lowercase s for seconds. And capital K for kelvins. Okay, let's talk about what these things measure. Meters measure distance. You've probably seen a meter stick before. Grams measure mass, how much matter is in something. It's a little bit different from the concept of weight, but at early levels you can think of it as the same as weight, even though it's different. Liters measure volume, how much space something takes up. That's why they're very useful for measuring liquids, which kind of take up, are contained in spatial containers. Seconds to measure time. We don't really like to mess around with minutes, hours, days, because these things come in groups of 60 or 24 or 365.4, whereas seconds are just easy. 1 second, 10 seconds, 100 seconds, etc. And then kelvins measure temperature. We don't use Fahrenheit because Fahrenheit's totally wacky. Water boils at 212 and it freezes at 32. That's why long ago, much of the world moved to the Celsius system, which is much better in the sense that water boils at 0 degrees Celsius. Did I say boils at 0? Freezes at 0 degrees Celsius and boils at 100 degrees Celsius. But there's a problem with that one too, and that is the coldest temperature possible, absolute 0, is negative 273 degrees Celsius. And so we have all these negative numbers, which are really weird for our calculations. So in order to fix that, we have this Kelvin unit named after Lord Kelvin that makes that coldest temperature possible negative 273 degrees Celsius. And it makes that just 0 kelvins. So the coldest temperature possible is just 0 kelvins, and then we go up from there. That means water freezes at 273 kelvins instead of 0. There's only positive numbers for kelvins. You might say, well, what about a temperature colder than negative 273 degrees Celsius? Well, as far as we know, no such temperature exists. That's actually the third law of thermodynamics, that you can't get any colder than absolute 0, the temperature at which all matter simply stops moving, has 0 kinetic energy. Okay, so these are the 5 SI units that I ask my students to memorize. There are other ones, but they cover more complicated things. Along with the SI base units, I usually ask my students to at least memorize a few prefixes. Now, SI prefixes go, as you might guess from the word prefix, in front of a unit, and they modify the unit by either making it bigger or smaller. And I'm sure you're familiar with this, you've seen them before. For instance, you might have seen a little c in front of m, centimeters. And so this C is the centi prefix, and that is 1/100th of a meter. That's an example of a prefix. You might see, for instance, a K in front of grams. That's kilo. That means 1,000. So 1 gram is roughly the mass of a paper clip. A kilogram is much heavier. That's the mass of 1,000 paper clips. Or, I don't know, like a nice heavy loaf of bread or something like that. In a 1 liter bottle, you might see that it has 1,000 milliliters. Milli is this M prefix, and it means 1/1000th. So there's 1,000 little milliliters, which is kind of like a little squirt of water in a 1 liter bottle. And then finally, the only other one that I ask my students to memorize is mega, which is a uppercase M. And that basically means a million. So you might have seen a millisecond before, which is 1/1000th of a second. A megasecond is a million seconds. And you might say that's a really weird way to measure time, but actually in computer programming, we measure everything in seconds. So we don't really mess around with days and hours and all that stuff. Of course, you can convert from seconds to all those things, but it's better to just work in seconds for everything. So a megasecond would just be a million seconds. Okay. The prefixes, as with the base units, casing matters. So centi is a lowercase c, kilos lowercase k, milli is a lowercase m, and mega is an uppercase m. And if you wanted to say, you know, milliliters, but you put an uppercase m in front of it, well, that's a megaliter, and you're putting in a totally different unit, right? So be very, very careful with casing. Milliliters is something you might measure the quantity of water in a teacup or something like that, whereas megaliters is something you would use to measure the mass of water, the volume of water in a lake or something like that. So be very careful with casing. In order to help you kind of remember these things, I think centi is probably one of the easiest prefixes to remember, because remember, centi means 1/100th, and there are lots of words that go along with this centi prefix. For instance, if you measure temperature in centigrade, that's Celsius, it's 1/100ths. A centurion is a Roman military leader that would have authority over 100 legionnaires. A century is 100 years. So centi's usually pretty easy to remember. It's 1/100th. Milli, I think, is also pretty easy to remember, because milli means 1/1000th. And you might know that there are 1,000 years in a millennium, for example. Mega is a little bit tougher. You just need to remember mega is a million. And kilo, same thing. You just need to know that it's 1,000. But usually people use kilo enough that they get used to that kilo prefix. So I think that's the absolute basic of SI units. If you know kind of the 4 main prefixes, there's a lot more: nano, pico, femto, etc. But centi, kilo, milli, and mega is a good place to start. And then of course the 5 base units: meters, grams, liters, seconds, and kelvins. The only other thing I would add is with kelvins, there's an easy way to convert to and from kelvins if you know degrees Celsius. So let's say something is, 25 degrees Celsius, close to room temperature, and we want to know what that temperature is in kelvins. Well, remember, zero kelvins is the same as negative 273 degrees Celsius. So how do you get from this temperature to that temperature? Now, it's important to know that each Kelvin is exactly the same increment as each degree Celsius. Kelvins are basically the same as degrees Celsius. The only difference is they've been shifted down so that 0 is the coldest temperature possible. So you can see the relationship here is that 0 kelvins is the same as negative 273 degrees Celsius, but we've added 273 to it. Likewise, if we were to look at how to get from kelvins back to degrees Celsius, if we were to go the other way, we're going from 0 to negative 273, we're subtracting 273. And so that's all you need to know about converting from Celsius to kelvins. When you're going from degrees Celsius to kelvins, you add 273, And when you're going from kelvins to degrees Celsius, you subtract 273. So this actually becomes just a really easy problem. We just take 25 degrees Celsius plus 273, and that's going to equal 298 kelvins. Okay, I hope you learned something about SI units here. I hope it helps you with your science class. I'll catch you next time.